Okay, let's do the programming. Mini mock. Right. So question 1. This is, again, a pretty easy question. I'm going to go to the easy ones first. Precondition loop. We know that a precondition loop is a loop which checks at the beginning. So that'll be your while loop, while something. This is your precondition to the loop. We know that a postcondition loop does the checking at the end of the loop. It uses a condition with until at the end of the loop, running at least once. Total. Well, we know that total is when you've got a variable plus another variable. This has to be a variable here. If it was a number, we would call that counting. Count. This is not count. They lie to you, and I've gone over this before. The purpose of this variable is simply there to ensure, well, it keeps track of the amount of iterations, but it's not actually counting. This is count, where we're having a variable plus a fixed value, a constant. So it could be value equals value plus 4. That would also, or 14 in this case, that would be count. Okay. I think the next one was this one. My advice is do it in Python first and then turn it into pseudocode. So that's what I'm going to do. Right now, go from using a single loop to output to no inputting the average of 50 numbers. Easy. So I'll have my number array. And I'm going to have my total. I'm going to have my average. I'm going to do a for loop. So for I in range, I'm going to loop 50 times. I appreciate that some people would have done length of number, but in pseudocode, it's easier if we just put in the value. Whilst I'm not doing pseudocode at the moment, it just makes it easier. I want the total to equal total plus number I, and then at the end of a loop, we do an average. Oh my god, my voice. I'm gonna pause for a second whilst I die. I don't know if that made it better, but whatever. Let's just carry on. Average equals the total divided by 50. This has to be outside the loop. And to output, we're going to do print average. Really easy code. So how do we turn this into pseudocode? I'm going to use black to do that. You did an array. Array. I'm going to change I to index. It's not going to be in range. It's going to be an arrow. I'm then going to do 1 to 50. So for index, arrow 1 to 50. Total equals total plus number, and inside of here, index. Then we go down. Average equals total divided by 50. That's fine. Not print average. Output average. And at the end of the for loop, we're going to do next index to make I go up by 1. Done. That's the pseudocode. It helped me doing the Python code first, so I can lay it out the way I want it to be laid out. Excuse me, I'm stretching. And I just replace it with my pseudocode in a different color. Nice and easy. You might want to use an eraser instead. The purpose of test data. So test data, let's get our heads around that, is when we want to use data to test out, see if a program runs the way we want it to run. So I've showed you quite a few times now. We've got our table where we've got like test number. We've got our test data. We've got our test type. And we've got expected outcome. So if I was testing, let's say putting in a score out of 100, my test data would be 8. The test type would be normal. Expected, it works. So accepted, I'm going to put. If I did 400, that's going to be abnormal. Rejected. If I did, so I said 0 to 100, so if I did 100 and 0, what we're testing now are extreme values. It should be accepted. And then if we did 100, 0, 101, -1, we're testing boundary. So we've got accepted, we've got reject. So this is our test data. This is our test table. What's the purpose of test data? To test to see if the code runs the way it is expected to run. We call this logical, we're looking for logical errors. So we're looking for logical errors. And for my example, I just need to give any of these. I can make up my own scenario. So I could do abnormal. Entering a score between 0 to 100, and I type in 10, which is a string, and it should be rejected. That says rejected in a really bad way. There you go. The purpose of test data is to see if the code runs the way it's expected to run, so we call that like logical testing, to look for logical errors. An example would be any from this table. You make it up because it doesn't give us any example, so we make up our own example, which is what I've done here. Score between 0 and 100. I've used abnormal, and I've given some test data to go with that. That is it. That easy. We then got a structure diagram. So this is part of design. This test table is part of testing in the system development lifecycle. If we go back to the structure chart, I'm going to have user input as one of my modules because it allows the user to enter the details. So user input for order and for pay. So order, pay, done. We've also got an output, or you can put display. I'm going to do display. Anyway, it's going to display the food as picture or list. That is it. There's no extra information. That is all we've got. That's all we need to use. Some people were doing stuff like this, and they added like payment information. It doesn't need that. We've then got spot the errors in the code. So be energy inefficient or use energy for binary algorithms we use the code to calculate energy values for data energy, and input efficiency is calculated in output as a percentage. The entry of a number -1 will stop the algorithm. But okay. So first thing I'm going to do is check the repeat. This should keep going until we type in -1. I can see straight away it's using keep repeating until it doesn't equal -1, so that is wrong. It needs to be that. So I would put line 11, I'll put what the mistake is, and then I'll do a correction, which is what I've done now. Make sure you do put what the mistake is. So that's the first one. So that's mistake number 1 done. We've got how many more? 3. Okay. Output. Enter total energy in. Fine. Input. Enter the total. So this bit. Good. Output. Enter useful energy out. Output. Useful energy out. Good. Nothing wrong with that. If total energy doesn't equal -1 and useful energy doesn't equal -1, fine. Oh, wait a minute, I spotted a mistake. This should be an input. So line 5 should be input. Useful energy out. So I put 5, I'll put what the mistake is, and then I'll put my fix. If total energy doesn't equal -1, okay, so what I'm going to do is I'm going to check the variable names. Total energy in. I check doesn't equal -1, that's fine. So this means doesn't equal. It's in the pseudocode guide I gave you on the knowledge organizer. And useful energy, but it's useful energy out. So that's the final mistake. It should be useful energy out. So line 6. We put useful energy, it should be useful energy out. I'm just going to go through the rest of it. We found 3 mistakes now, but just to double check. Yep. We have to look at the efficiency, we output it. It doesn't say that we do the output after, it says we just output it, so that's what we're doing, so that's fine. We don't need to put this outside the loop. Okay, I'm happy with that. 3 mistakes found. Alright, we've got our logic gate. A is 1. B is not 1. Because it's not B. So I've done that, and I've done that. I'm going to join them up with an OR gate. All that's done. I jump to this side. B is 1. We're using B again, so you do a straight line. B just means B is 1. C is not 1. We join that to that with an AND gate. Done. We finish this off. With an AND gate. Done. This is a database table. How many records are part of this database? Let's get this into our heads. These are fields. Do not count these. It doesn't say how many fields, it says how many records. Records is the data which makes up a row. So this is, or shall I say, let me rephrase that. The record is a row. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Don't just look at this and say, oh, it's 31 because we've got BK31. No, because their number's missing. Their record's missing. So we've got 20. What field would we use as our primary key? Obviously, that will be cat number. It basically means that you can't have repeats. It's what makes it unique. You might say to me, yeah, but you could have, well, if we look at these titles, each one of these are different. Yeah, great, but you could have someone else who wrote a book called The Dark Tower, their own Dark Tower book. It could happen. That means we can't make this unique, but what can be unique is an ID number, which is the cat number. Okay, these are some queries. So we need to output or show the output of this query. So let's just highlight what's important. We want cat number, we want title, and we want author. Look at what I'm doing. This is what I expect you to do in the exam. We also want to care about stock level, but we don't care about anything apart from if it's got a stock level of 0. So this has got 0 and this has got 0. It doesn't have anything like order by. So if it did order by cat number and I had it as descending order, that would mean that we do this one first. So we'll do BK31 networking for beginners, blah, 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 blah. But it doesn't. Because it's got no order by, we do it in ascending order by default. Ascending order would be the first one we deal with, which is BK08. This is how I want you to write it out. You do it on the same line. We then do title, which is the princess's story. We then do the author, which is B pen. We then move on to the next one on the next line, which is BK31, networking for beginners. And the author is A. Smith. Done. Easy 2 marks. Remember, if it's got an order by, you check what field it's ordered by and whether it's descending or ascending. So if it did order by author, DESC, we find the author with the last name to go, well, like the highest value name. So A. Smith starts with an A. And who's the other one? It was B pen. So we'll still do B pen first. So it'll still be BK08, Princess Story, yes. B pen, blah, 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 blah. And then it'll be BK31. But if it was ascending order, so if we did it by author ascending, it'll mean that we'll do BK31 first because A is before B. So we'll do BK31 networking for beginners, A. Smith, so that'll go first. But again, it doesn't have that, so we're happy. Okay. And finally, let's complete this SQL statement. Select, we want to display all the titles, so it's just title. That's the only thing we want to display. Display all titles. It doesn't say display the author, it just says display the title. From table book list, where author equals, like you would do, and speech marks because it's a string, it's text, B pen. Semicolon. It has to have speech marks around it.